Welcome to Arcs and Sectors. So just a reminder that an arc is the distance on the outside of a circle. Obviously, if it's a full length, it's a circumference. But when we talk about an arc, we talk about a distance between 2 points on the outside. Using our formula with degrees, the length we used to use was L equals theta over 360 times 2 pi r, because it's a fraction out of 360 of the circumference. That's how we get the length. Changing it now to radians, so we're going to use radian measures. 360 degrees is 2 pi, and that 2 pi cancels with the 2 pi in the 2 pi r. And so our length in radians is r theta. So for this, we need to make sure that theta is in radians. The area of a sector. So the area of a sector is like cutting a piece of cake from the centre to the outside using both of the radii and including the arc. So the area is theta over 360 because it's a part of the full circle times pi r squared, the area of a full circle. Change the 360 to 2 pi to change it to a radians measure. Notice that the pi's cancel and you get a half r squared theta. So the area of a sector using radians, where theta must be in radians, is a half r squared theta. Now the reason we use this is that the formula makes things a bit easier to calculate or to get exact answers. So we're going to look at calculating the exact area and perimeter of the following sector. So it's got a 45 degrees. So we want to change that to radians, and it's got a radius of 10. So 45 degrees is 45 pi over 180, or pi on 4. And so we're going to sub that into our area formula, half r squared theta. So remember our radius was 10, and our theta is pi on 4. So substituting that in, we get a half times 10 squared times pi on 4. A half of 10 squared, so half of 100 is 50, so that's 50 pi on 4. Simplifying that, you get 25 pi on 2 units squared. That's an exact answer, which is what we're after. To do the perimeter, so the perimeter is the distance on the outside. So not only is it the length of the arc, it's plus the 2 radii that we've been given. So the length of the arc is r theta plus the 2 radii. So 10 times pi on 4 plus 2 times 10. So 10 times pi on 4 is 10 pi on 4, or 5 pi on 2, and 2 tens are 20 units. Thank you.